The Tour de France, the famous annual cycling race, took place for the 100th time in 2013. The data set contains the times for each of the 21 stages completed by the 198 starters. The aim is to display well-known characteristics of the race and discover additional interesting features, all using interactive graphics. Questions include, do a lot of riders drop out? Where is the race won? And how do the riders perform? For each rider, the data set includes his name, team, height, weight, year of birth. Then there are the times for each stage, the cumulative times by the end of each stage, and the standings, the race positions, the variables noted R1 to R21, at the end of each stage. How many dropped out? A missing value plot of the times for the 21 stages, here, shows that the first stage where anyone dropped out was stage 3, and querying that we see that 2 riders dropped out. By the end of stage 21, if we select the group of dropouts, 29 had dropped out, as you can see here at the bottom of the variable window. That's about 1 in 7 of the riders overall. And now if we take the teams and do a bar chart showing the number in each team, we also see the dropouts highlighted. And you can notice that some teams, Belkin, Katusha for instance, had no dropouts, and Astana had the most. Querying it shows 4 out of 9 dropped out. And if we sort and look there, sorting by the absolute selected, there were 7 teams who had no dropouts, and there's Astana again with the most dropouts. The time taken for the whole race is the cumulative time for all 21 stages. Drawing a histogram, changing aspect ratio a bit, and then choosing a better bin width. Something like 3 minutes or 180 seconds would probably be a good idea. Let's just put in the value there of 180. And just rescale that so we get the overall picture. We see here, right at the beginning, the eventual winner, Chris Froome, who took just under 84 hours. At the end, the person taking the longest time, Sven Tuft, the red lantern of the race, was just about 4.5 hours behind, and the number there on the right underneath the axis is his time in seconds. So we can also look at the riders by drawing a bar chart of the names, and putting that up and scrolling down, we find there's Sven Tuft selected. And if we want to pick out Chris Froome, we can just start typing his name, and there he appears at the top of the list, and when we select him, you see him here, the yellow jersey winner with the shortest time for the race. What happened in the stages? Well, drawing a parallel coordinate plot of all the individual stage times, we get a not particularly helpful graphic initially. But if we put them all the axes on a common scale, let's just change the size of the window first, then get the pop-up, scale each individual axis, we see that some stages took rather less time than others. Stage 4, the team time trial, the other 2 time trials, stage 11 and stage 17. Some stages took much longer, obviously the mountain stages like stage 15, stage 18, stage 19. But if we want to make comparisons, we really need to use a different scaling, and we can get that by aligning every axis at its median, roughly the time of the peloton for the race. And now we still have Chris Froome highlighted, that red line at the bottom, and we can see individual structures. Stage 1, everyone was awarded the same time because there was some sort of mess up with one of the team buses at the finishing line. Then we can see stages like stage 8, the first mountain stage, where there was quite a lot of variability. Stage 9, a hilly stage, also a lot of variability. Stage 15, 18, 19, 20, mountain stages, a lot of big differences in times between the riders. On the other hand, we have the team time trial stage 4, not much difference. Stage 11, not much difference. And then stage 12, a flat stage, where really there weren't many noticeable differences. And stage 21, the final stage into Paris, which is really a triumphant march in for or ride in for the eventual winner. There are a couple of stages with odd patterns, stage 5 and stage 7, where the field split into two. If we select the slower lot on that particular stage, they were generally weaker riders overall, as we can see also for stage 5, linking to the histogram of total times. Here we have a rider selected who was very slow on stage 8, dropped out in stage 9. And then there's Jonathan Hiver on stage 15. He was over 50 minutes behind every other rider, but just managed to get the cut-off, and then the next few days actually did reasonably well. Going back to Chris Froome, we can align all the axes at his time. And then, after using alpha blending, we see him clearly this straight line, and we notice that he was always at the front, almost always at the front of every stage, with just a few stages where other riders had better times. And the black lines you see are stages where large groups of riders had the same times in both stages. That's probably the peloton, basically. Rather than looking at individual stages, let's look at the progress of the race and draw a parallel coordinate plot for the cumulative times. So we do that just the way we did it before. And now again we do a common scaling, and you see the steadily climbing cumulative times, but then aligning them at the median, we get the overall picture with small differences at the beginning, at the early stages, and obviously the biggest differences towards the end of the race. And then if we highlight Chris Froome again, we can see that once he took the lead, he had a fairly good puffer between himself and the riders behind, at least a fairly good puffer in terms of time for the Tour de France. So he really had the race under control. We can also see here some changes, riders doing better, riders doing worse, but we can hardly see anything at the beginning where the times are rather small. So an alternative is to look at the standings, the ranks throughout the race. Again, we'll use parallel coordinates, and again we'll use common scaling, because don't forget, a number of riders dropped out. So actually we have about 30 riders less at the end than at the beginning, and therefore we have fewer rankings. Selecting Chris Froome on the total times, we see him highlighted here on the rankings. Initially, he's not at the front, doesn't hold the yellow jersey, but on the other hand, the time differences here are very small, and if you go back to the total time parallel coordinate plot, that makes that clear as well. From stage 8, which he won, and stage 9, he was really always in the lead. If you look at stage 2 here, this is the movement from stage 1 to stage 2, you see a lot of changes. Same thing on stage 3, and then really the important changes start coming on stage 8, the first mountain stage, and stage 9, the following hilly stage. The next 3 stages, 2 of them were flat, and there was a time trial, stage 11, stage 17, the other time trial, and stage 21, the final stage into Paris. On all these stages, nothing much happened in terms of changes of standings. Where the race really happened is on the mountain stages, stage 15, 16, 18, 19, 20, and of course stage 8, the first mountain stage. The main results of our analysis are that in 2013, about 1 in 7 of the riders dropped out during the race. Looking at individual stages, many riders are allotted the same time, especially on flat stages, and the overall standings barely change. Early on, when the time differences are small, the riders' standings can change quite a lot. With the time trials, the differences are actually small, though obviously they're important for otherwise equally strong riders. The race is really decided on the stages where there are big time differences, the mountain stages, and only good climbers can get one of the top places. This is all well known to Tour de France fans. We've confirmed it through exploratory data analysis and found several interesting additional features along the way. This analysis was carried out using Martin Teusser's Mondrian. Mondrian runs on all platforms and may be downloaded for free from this web address.